everyone. Welcome back. Welcome back to my math channel online today. In this video today, I will discuss with you about the topic of permutation and combination that I have created and presented on my MS PowerPoint presentation. And I have provided on of my student the formula, and I have shown you how to use the calculator to calculate permutation and combination. This video is just provide you a solid concept of the two different topics. And today, these two topics will mix together in the question, which is trigger our thinking. Wait a minute, do we use permutation or do we use a combination to answer the math question? I found this topic is fascinating in the way that it gives us a lot of information for us to think about, and all the information are practical and present those questions come up in our real life problems. And sometimes we just think of it and answer it for fun. So we can think this way or we can think that way, but the answer will tell us that our institution, our thinking, our thoughts are logical or not. And of course, if we think logically, the answer will be correct. If we don't think in a way that mathematical concept, then we will guess the incorrect answer. But it will make us to feel fun to answer this question. I hope so. So I will share with you the lesson today. And if you register to my math courses online, this lesson is very useful for you to learn in this topic. Now, I also let you know that sometimes as a teacher working in the school classroom, I understand that our teaching were restricted and limited by the resource, by the times management, by the way we have to handle classroom management. And if we have to deal with the students, sometimes we don't even have time to teach, and the other students don't even have time to learn. If we divide 50 minutes and give each student a differentiated lesson plans, then that is unrealistic, because each student will only have 5 minutes from the teacher. And in 5 minutes, if you just look at the paper and just prepare to get the paper out and get out your pencil, that 5 minutes has gone. And therefore, we have to follow the level of the majority in the student to do our lesson plans. And even though we want to give more information, sometimes we have to be limited by that. But my math course online were not restricted by those factors. And therefore, each way of method of teaching have the disadvantage and the advantage. If you can learn online, you can learn in the depth knowledge, in the depthness, and more thoroughly, more details and more concepts you can learn, which were restricted in the way you learn in your public school, to be honest with you. Even though the same teacher, but we have to design our lesson depend on the environment and depend on the classroom environment. And therefore, online environment give you the opportunity, the chance to learn more in-depthness. And if you are working hard, if you are working students, you would love to learn online education, because you will learn more and you will understand better. It's the same like private tutoring individual. Anyway, July 3rd is the date for all students around the world who interested in my math courses online. You can register, and if you watch my topic of permutation combination, I have posted the website there. Also, I will provide you the website today as well. And if you have a chance, just write down. And if you're interested in learning math more in the way that you understand better and more thoroughly, then you can register to my math courses online. So let me share the screen with you today, and let me get into the topic today. So I'm going to share with you the whiteboard, and I will type in the question today. Okay, so let me type in the question today, and let me give you, you can visit my March courses online. Go to my math teaching.ca. You can read my professional profile there, my experience, how do I teach, what is my resume, what is my portfolio, professional portfolio. You can read the whole professional portfolio. And you can watch some of the weekly lesson plans I post there, and just have drop by and have a chance to visit, to have some fun. Okay, so that is the my own website, my mathteaching.ca, very simple. You even though can remember that. And to register to my math course, you can go to http math course online.teachable.com. So that is another website for you to register to our math courses online. And I'm going to key in the topic today. So the topic today we will discuss is permutation. This will be included in my math courses online in the course of Pre-Calculus Math 12. Permutation and combination. Now, the question today will have a lot of fun because they will be mixed up together, and you will not be able to guess which one is the combination and which one is permutation. However, I will provide you the solution, but should give it a thought first. When I'm typing the question, you can think about it. So the first question is, 120-room hotel has reservation from 6 guests for 6 different rooms. In how many ways can the room be assigned? So I let you have one moment to think about how we're going to answer this question. Now, first we have to know, is this a permutation problem or is this the combination problem, right? Let me remind you about permutation mean the order is important. For example, if you have 5 people with the different names, Lan, Tom, Jim, Alice, Sam, line up for a photo, then you want to arrange these 5 people in the photo. Sam will stand beside Lan, Lan will stand beside Tom, Tom will stand beside Jim. So that is the first possible. Then the second possible, then Jim will go first and then Lan beside, and then alternate each other. And each photo are different, so we have to count them on. And that is the concept of permutation, which is give us a lot of chance, a lot of possible outcomes. Whereas the combination, if you go to the restaurant, you order a sandwich. So the order is not important. If you put 1 tomato in, cucumber in, and lettuce in, so you go tomato first, lettuce, and then cucumber. The same like you put cucumber first and then put tomato and then put lettuce. So you only count at 1 chance, 1 possible outcome, 1 choice of your sandwich instead of 2 choices. But in permutation, we double counts. So therefore, because the order is important, so it's always a lot more than combination. So that's just my review for you before we get into the answer. So in this question, we assign 120 room hotel for 6 guests. Now the first guest will have 120 choice. Let's say the room count from number 1 to 120. And of course, the room number 2 will be different from room number 1. Maybe the room number 2 will face the window, or the room number 1 will face the backyard, something like that, right? So therefore, they are different and we have to count. So therefore, the first guest will have 120 choice to select the room. The second guest only have 119 left, and the third guest only have 118 left. So this is a permutation problem. And therefore, the answer will be 120 to 6. That's the answer. And 120 to 6, if you use a calculator, I have already shown you before, right, how you can use a calculator. So I don't want to take a lot of time today. So maybe I just remind for you. So you can key in 120, right? 120, and key in math, and then move your cursor to the last number, and then you can key in the number 2. Now, if permutation, you key in number 2 to get NPR. If combination, you will key in number 3 to get NCR. So in this case, you will key in the number 6 beside that, the NPR, and I hope you can see right from here. And then you enter. So the answer is very big. It will be 2.6 times 10 to the power 12. So that's the answer. Now, sometimes you might say, oh, why it's too big like that? It doesn't make sense. But that makes sense in math. Now, sometimes we're tricky. We just give you a very strange number, like a possibility is a huge possibility. You might confuse, but if you understand the theory and the theorem lie behind it, then you won't say, oh, it's unreasonable, right? Because that's the way it is. Okay, so that's the first question. Now I'm going to key in the second question. So our second question will be, how many different groups of 4 letters can be made from A, B, C, D, E, F. So there are 5 of them, A, B, C, D, E, F. Actually, 6 of them, right? 1, 2, 3, 4, 5, 6. Yes, 6 of them. If the letter can only be used once. So that's the question. How many different group of 4 letters can be made? Now, it will be a little bit different if you ask how many different possible outcomes of the arrangement of 6 letters. Then the answer is just 6 permutation. 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. But this is the question asks about the groups of 4 letters. So the answer, usually when we're talking about the different letters arrangement, usually is the permutation case, but it depends on, right, the question. But in this case, yes, of course, it's still permutation. So the answer would just be 6 to 4, because you want to form the different group of letters. Now, let me show you the sample of it. So the answer will be 360 choice. Now, let me explain it, right? So explain. Now, the first group, right, of 4 might be A, B, C, D. That's the first choice you have, right? Then the second choice, you will have a D, E, A, B. And then the third choice, you might have C, D, E, A. And so on, of course, right? So now you understand that. And then in total, if we really list them on the paper and we write down, or we draw the factor trees, diagrams, we will count at the end, we will get the answer 360, which is a lot and tedious task. And we don't want to do that. We want to use math to count, and we got 360 easily if we think logically, like a mathematician. Everyone can be a mathematician, except not me. Okay, so I'm just joking. Now let's do number 3. And actually that's true. I never can be a mathematician. I can be a teacher, a math teacher, but not easy to be a mathematician. I'm not that genius, right? So anyway, let's read the second question. So the third question I have for you will be a sample of 5 people are selected from 3 smokers and 12 non-smoker. In how many ways can the 5 people be selected? So let's think about this question. You have 5 people line up, and there are, actually you have 15 people, right? You want to choose 5 people from 15 people, 3 smokers and 12 non-smokers. In how many ways can the 5 people be selected? Now, this question doesn't tell us how many smokers we're going to choose or how many non-smokers we want to form. It doesn't say. And therefore, instead of separate them, the easy way for us, we will just add them together, which is 12 at 5 no, sorry, 3 and 12, right? 3 smoker and 12 non-smokers. So the total would be 15 people. And we want to choose 5 people. Now, we're going to have to make a choice. Do we use P, permutation, to choose 5? Or do we use combination to choose 5? And of course, the formula to calculate for combination is different from the formula to find the permutation, right? We're going to use a calculator in this case as well. So the matter is, as long as we know is that 15C5 or 15P5, P for permutation and C for combination. As long as we choose right, we can use a calculator and answer and get the answer now, it's no problem. But we have to know whether we use P or we use C. So if you think in 1 minute, right? If we want to pick 5 people from a group of 15 people, now it doesn't matter, you can pick Mai, Lan, Tom, and then Jane, and then Samba. Or you can pick Samba first, and then Jane, and then another person, let's say Jack and Jim instead. As long as you can form a group of 5 people, you can select the sample like that from 3 smoker and 12 non-smoker. The question doesn't give you a condition that you have to choose 2 smoker or 3 non-smoker. So we just go ahead, add them together as 15 people, and we choose 5. That is a combination because the order is not important. You can choose Jim first and then Tom later, or you can choose Tom first and then Jim and then Sam. Doesn't matter, you count as one time. So 5 people line up, right? Tom, Sam, Mai, Alice, Jane. If you reorder it, Jane, Tom, Alice, Mai, doesn't matter, you count as one group of 5 people. So this is the combination problem. And 15 to 5, the answer is 3,003 possible ways. That's the answer. And again, I can show you how to use calculator maybe one more time. I'm going to go back to here and show you. So let's say I'm going to stop share, right? So you can see that on your calculator here, you will enter 15 like that, and you go math, you hit math button, the math button here, and you go the arrow, you go to the end, right? So the end is the probability, and it will show you number 2 NPR, number 3 NCR. And this is the combination. So you press number 3, which is NCR on your calculator. So you have 15 NCR. And then now you key in 15 to 5. So you key 5 beside it, and you hit enter. And you get the answer, 3,003 possible ways. So the calculation is not a matter, but the way we think whether this is the permutation or combination is the important thing to answer this question. You can learn how to operate the calculator and get the answer, or you can use a formula, it doesn't matter. And of course, the formula based on the factorial notation, right? So I'm going to share the screen again with you. So this is our question 3. Let's go to the next question, right? And let me know why we cannot move down. Should give me 1 minute. See if I can handle this bar. No. So I'm going to have to erase it. I'm going to clear this one. Don't forget to copy my website, right? I'm going to clear this. So I'm going to go back to the next question, which is interesting question number 4. You have a penny, a nickel, a dime, a quarter, a loonie, and a toonie in your pocket. If you pull out 3 coins, how many different sums are possible? Okay, so I'm going to give you 1 minute to think about this question. How many sums possible? Now, if you pull out 1 penny plus 1 dime plus 1 nickel, then how much you have? 1 dime is 10 cents, 1 nickel is 5 cents, and 1 penny, so you have 16 cents, right? If you pull out a quarter, and then a toonie and a loonie, you have $3.25. If you pull out 3 coins, which are a loonie and a penny and a nickel, then you have $2.07, right? $2.07. Sorry, 6 cents. That is another sum. So there are many sums different, right? If you pull out 3 coins and they are different, then you have all different sums. So how many possible sums you will have? And is this a permutation counting or a combination counting? Now, if it's a permutation, then there are a lot of possible ways, right? Possible sums. But if you count as the combination, then it's less than. So how do we do this one? And what is the combination and the permutation? So let me give you a hint, right? If you pull out P and D, that will be different from P and Q, right? Penny, nickel, and quarter. And that will be different from if you change the order, right? Let's say if you change the order, let's say if you change the order, you change N first, and then P first, and then Q first. Now, is this 2 choice here, you count it as 1 choice or you count as 2 choice? If you put out penny first, and then nickel and quarter, or you put out from your pocket nickel first, and then a penny and a quarter. Now, even though you reverse the order, NPQ or PNQ, it doesn't matter, right? The sum is still the same. 1 penny with 1 nickel will be 6 cents. At a quarter, 25, at 6, you will have 31 cents. So regardless, the order of P and Q, you have 31 cents as one sum. Or NPQ, you still have 31 cents. So this cannot be a permutation. It has to be combination. So the answer will be, so the solution will be, how many coins you have? 1 penny, 1 nickel, 1 dime, 1 quarter, a loonie and toonie. So again, you will have 6, 2, 3 combination, right? And 6, 2, 3, the answer will be 6 to 3, your answer will be 20, some possible. Now, so what is a 6 to 3 mean? If in formula, you can count as 6 permutation, right? Divided by n minus r, which is 3 permutation times 3 permutation. And that's the same, you get the answer, 20 possible sum. Possible sum. That's the answer. So that's the question 4. I'm going to go to the next question, which is question 5. I'm going to choose on the interesting question, right? 10 college students, including a married couple, are eligible to attend a national conference. 4 students can attend. The married couple will only go as a pair. You don't want to go separate, right? How many different possibilities are possible? So in this question, let's read one more time. 10 college students, so you have 10 students, including a married couple. So if we deduct a married couple, will be a student left, right? Are eligible to attend a conference. So we choose 4 students to attend. The married couple will only go as a pair. How many different? So in the scenario, we have to analyze in cases, right? So let's say if the first case, case 1, the married couple decided to go, right? The married couple, because they can go together, go together, so they say, okay, we will go. So the married couple will go. Now, in the scenario, then the choice for the 2 people of the couple will be just one choice, right? There's only one possibility. You pick it, which is for the married couple to go. So that will be one choice. By fundamental counting, we will multiply with another choice, which is one we already picked 2 people, there are 8 people left for us to choose from, right? And again, this is a group of people, we don't care about who go first. As long as the group of 4 students, whether my first and Lan second count the same as Lan first and my second, right? So this is a combination. So we're going to say A choose, C stand for combination, A choose 2. That is the answer because we subtract the married couple. We only choose 4 of them, but the married couple decided to go. So the rest of 8 people, we choose 2 students to join with the married couple to go. So A choose 2 times 1. In this case, the answer will be 28. Now, I'm not going to show you how to get the answer anymore because to save time, I just type in the answer, right? You know how to operate using the calculator now. Any calculator will have it. Now, in case 2, let's say in case 2, the couple will not go. Will not go. So in case they are not go, how do we count? the counting will become 10. Sorry, they not go, so still A, right? 2, 4. And A to 4 will become 70. So now we will use the condition either or, right? Either they will go or they don't go. So the total possible outcome, either they go or they don't go. We add them together, will be 70 adding 28. And that will be equal 98 is the answer. 98 possible outcome, or just say 98 ways. So that's how we answer question 5. Let's do the next question, which is question 6. So let me key in the question 6. So the question 6 say, a person must deliver packages to 6 different locations. So question 6, a person must deliver packages to 6 locations. If the order is randomly, I don't know why I cannot move it down. Usually I type in like this, it should move down for me, but it not move down. I have no idea. Okay, so what I'm going to do, I'm going to erase the first. Oh, sorry. Now I have to key everything again. Sorry for technical problem. We have to key in again. So number 6, a person must deliver 6 packages to 6 locations. If the order randomly determine how many routes are possible. If the exact opposite route does not count as a different route. So this is the question. A person, sorry for misspelling, a person must deliver 6 packages to 6 locations. If the order randomly determine how many routes, and sorry, routes should be like this, are possible. If the exact possible route does not count as different routes. So let me give you a hint, right? Let's say you start from the route 1, right? Let's say route 1, highway 1, or highway 2, highway 3, right? Route 1, then you go to route 2, right? Route 2, and then you go to route 3, and then you go to route 4, and then you go to a long way. Let's see, route 4, maybe route 4 shorter than route 5, shorter, and then you go to route 5 is a long route, and finally you get to route 6 to 6 location, right? Now, when they say opposite, what does that mean? I mean, you will count opposite, right? So we will 6 backward, right? Backward to 5, and then to 4, and then backward to 3. That means opposite, right? Backward to 2, and backward to 1. So the first is the forward, and the second backward in the opposite direction. And if there are 2 directions like this, from root 1 to root 2 to 3, then you count as 1 possible choice. But the turning back, we don't count as the second. We just count as the 1. So what do you think the answer will be in this case? So in this case, right, the answer, now, this is a little bit tricky, right? You see that, right? When we apply the permutation or combination, now it's getting into a more difficult level. We have to think. Now, if you think that there are 2 possible choices, but you only count at 1, it's like you divide by half, right? So this way is the root. Does this important or not important? This permutation problem, the order is important. Of course, the order is important, right? If you choose the root highway 2, you go first, and then you jump to highway 3, and you jump to highway 5, and you go to highway 4. The order is different. It's different way of possible routes you can go, right? So the order is important in this case, and it must be a permutation problem, which is you have 6 factorial, right? Because you have 6 roots to count, right? 6 factorial. However, because 2 of them count as 1, so this is not a combination, it's still a permutation, but you have to divide it down, right? And you will divide by 2 to halfway, right? You count as a halfway, right? Half choice. So the answer will be 6 permutation divided by 2, and the answer will be 360 routes, possible routes to go. If you don't count the opposite route, including it, the answer will be 360. That's a lot, right? Okay, so that is the question 6. And I'm going to the next question, which is question 7. So let me clear this so I have room. So now let's do the question 7. So the question 7 is, how many ways can 5 people A, B, C, D, E sit in a row? If A must be to the left of the person B, but not necessarily next to each other. So you see, each question are totally different scenario, right? Have a different scenario, and we have to analyze it when we answer it. So let me present the scenario to you, right? So in our first scenario, let's say you have a scenario like the conditions say as long as B sit on the left of the A on the left of B, of the B person. Now all of these people can sit anywhere, right? it can be A, B, C, D, or can be C, D, E, B, A, right? But as long as the A have to be on the left, not the right-hand side, right, of the B person. So maybe we will have an A, and they're not next to each other, so you cannot put B. It have to be C, and D, and E, and B. Maybe that's the first scenario. Now the second way could be, second scenario of arrangement, maybe will be C first, and then D, and then A, and then E, and then B. So that's the second way, right? A on the left of B, but not next to each other. Now the third one might be maybe E first, and then C, and then A again, but then not B, right? Because they cannot be together. So got to be D and B. So that's the three scenario I just showed you. How many possible ways of it we can count without mathematics? Can we count on our finger? Let's see, right? So that's the way. Now, so we treat A as on the left of B. Now, this way, we can think of it as halfway on the left side, right? So it's similar to the previous problem I showed you, halfway of the roots, right? This is halfway of the left side of the B person. So the answer, now again, because the order is important, right? You put the first person on the row, whether take a picture or maybe sit to watching the video game, still important, right? Because let's say if I like to sit beside Tom, I don't want to sit beside Alice, right? Maybe Alice want to sit beside Jane instead of beside Tom. So that will be different, right? So we have to count. We have to take in the consideration of the order is important in this case. So that will be permutation. Now, how many permutation? A, B, C, D, E. We have 5 people to arrange. So will be 5 permutation. However, we count halfway because A have to be on the left of B person. So we will divide by 2, which is the answer is 120 for 5 permutation divided by 2 equals 60 possible outcome of arrangement, ways of arrangement as long as A to the left of B. Okay, so that's how you answer that question. I don't know, should I give you another question maybe? Let's give you a last question. Otherwise, this video will be too long, right? I will continue to the next video. But let's give you another question, the last question. So let's clear this. When the question A, so for question A, you have A, people. The scenario is just like we have it in question 7, right? So you have 5 people, name A, B, C, D, E. You have 5 people like that. And the question asks, how many ways these 5 people can be arranged if person A and person B must not be together. So that is the question 8. Now, in this scenario, again, because the different people and the order is important, right? So if you have A sit beside B, how many ways these 5 people can be arranged? Can be actually not arranged, but can be seated. Can be seated. So you want to sit these people together, right? So A maybe sit beside B and B maybe sit beside C and D. However, they say that the question say A and B must not be together. So the first scenario could be, let's say the first case could be A and okay, before we do this, let me talk about, instead of try to do case 1, case 2, and see that it will be a tedious task to do. So the easy way I suggest to do in this question is using the formula no restriction minus the case that A and B together. And that is like a counterpart, like the opposite with the question say if A and B must not be together. So when we say no restriction, minus subtract on the possibility of A and B together, that will be equivalent to A and B not together. So in that way, it will be easier for us to answer the question rather than present in a different cases. At the end, it's still right if you go forward, straightforward answer directly when A and B must not be together. But in this way, if you use no restriction minus the case of A and B together. So let's talk about A and B together first, right? So when A and B together, then case 1 could be AB, and then C, and then D, and then E. Or case 2 could be C and A and B, and then D and E. So the scenario like that happened, right? Or you might swap between case 3, might be the same like the first one, but instead of A first and then B first, now you can swap them, B, A, and then C, and then D, and then E, and so on, right? So that's the way. So let's say if you have 5 people and you count A and B together as one choice, then the choice of possibility when A and B together will be one choice, right? That's always possible like that, just one choice, time with, and because even though you treat them as one person, A and B together as one person, but you still have to arrange them, right? So therefore, you count at 1, 2, 3, 4. So therefore, will be for permutation, for factorial, because the order is important in this case, right? You want to sit them, and the way they change their sitting position then must be counted, right, as a different order. So 1 time with for permutation, for arrangement, when A and B together, and you treat them as one person, right? However, because the swatching between A and B, so we have to multiply with 2. So the answer will be for permutation, 4 times 3, which is 12. 12 times 2. So you're swatching them, right? So yeah, you treat them as one couple, one person. So you have 4 permutation instead of 5, right? We have 4 permutation, and they exchange their position between A and B. So therefore, it will be 4 permutation multiplied with 2. And 4 permutation will be 4 times 3 times 2 times 2 will be equal 48. So now if we use no restriction, will be 5 permutation minus the A and B together will be 48. And the answer will be 120 minus 48, and that will give us 72. Yeah. So 72 possible ways. So that's how we answer for question 8. Now at this time, I would like to stop here, right? I would like to stop here because otherwise it will be a very long video, and I will continue because I will, in my lesson plans, I assign 20 different questions in the assignment to give you and different scenarios. So I would like to go through with you. I found this topic a little bit tricky, right? In the way we think sometimes. So I will walk you through 20 questions. So I'm going to stop our video here, and I will continue with this video for the rest of the, so we're done with 8 questions. We will have another 12 questions to go. And I hope you enjoyed this video. So I will talk to you again, and I will see you in my next video, which is, we'll continue with this topic again. And you will see a lot more interesting questions in our next video. So stay tuned for that. And thank you for watching. Bye for now, everyone.